Alright guys, today we're going to be graphing quadratic inequalities and also solving for x on a number line with quadratic inequalities. The first two we're going to do is graphing. So we have y's and x's, which means we want the whole graph. We are going to shade false. And basically all you do is enter in your quadratic into your calculator like we did before the first quiz. But the only thing you have to note is what kind of line you're going to have. This is going to be a dashed line, and this is going to be a solid line. Okay? So when you enter this into your calculator, you guys could do that on your own right now. You should get the following points. You should get 1, -4, 2, -3, 0, -3, 4, 5, and -2, 5. And then the zeros should be at -1, 0, and 3, 0. So it should look something like that. Next thing you do is draw the line. Again, this one is dashed because it is not a greater than or less than and equal to. And again, we're going to shade false here. So now you have to pick a test point. I like to pick 0, 0. So I'm going to put a 0 in. 0 minus 0 minus 3. So is 0 less than -3? This is false. And we like to shade false, so we want to shade inside. So that's all there is to it. Okay, so that is that one. So why don't you guys try the next one on your own? I'm going to pause it and then get the points for you right away. So, but try to plug that one in your calculator and graph it first yourself. Okay, when you put in all the points and you looked at your calculator, you should have had a bunch of, it's not really symmetrical. So you should have had your zeros at 3, 0 and -0.50 with a max at 1.25 and 6.125 is your vertex. And then you could just graph the points that matter here. In this case, we have a solid line. So let's graph this. There's the top. Okay, and now we have to do a test point. Let's try 0, 0 again. Is 0 less than or equal to 0 plus 0 plus 3? 0 is less than or equal to 3. That is true. We do not want to shade true. We want to shade false. So that means that we're going to shade everything outside of this parabola. Okay, so that is graphing a system of, or not graphing a system, that's just graphing a quadratic inequality. Pretty similar to just graphing the doing the inequality, but then you just have to figure out which way to shade and what kind of line you have, just like when we did linear. Alright, so now we're going to be doing graphing a system of inequalities. We are going to leave the answer true. So that means that we are shading false again. So again, we have to take care of both of these individual graphs. Alright, so why don't you guys try to plot those right now? Okay, I have now plotted both quadratics. Actually, I probably should add 2 more points for this one. -4, -9 is one of them. And the other way would probably be 3, -9. So make sure you plot. Now on this one, I just need good points. I don't need the zeros if they're not nice. It's good to know where the vertex is though, just so it's easier to plot the top. So 3, -9 is the other one. Okay, so these are my 2 quadratics. The blue one, which is this one, this is the blue one that I did, has a equal sign, so this should be solid line. So I'm going to graph that now with a solid line. And that's what that one should have looked like. The red one, though, is, this is the red one, is not a solid line, it's a dashed line. So that, yeah, now that's supposed to look like a dash. Okay, so now we have to graph false for both of these. Now you kind of have to be careful when you do this. So ignore the other parabola while you're doing this for now. You can test 0, 0 for each one. So let's do 0, 0 for this blue one. Is 0 greater than or equal to -9? Yes. So that means the inside is true. So we want to shade outside the blue one. Okay? Now let's try 0, 0 for the other one. Is 0 less than 3? Because those become zeros when you plug them in. That is also true. That means we do not want to shade inside this one. We want to shade outside the other parabola too. So what happens here is all of this is shaded. So basically the solution to both quadratics is that middle section that looks kind of like an ellipse, because those two things do not those things satisfy the both quadratic inequalities. So that is how you graph a system of quadratics. Again, very similar to graphing systems before. We're just using quadratic graphs. Okay, so now we're going to be doing the same thing, but we're going to be solving by graphing now instead. Now, little trick for this. If it's a standard x squared problem, so not negative, negative flips it around, but it is just standard x squared right now. This is less than again. And then this would be greater. We talked about this in chapter 1. Okay? So what I need from you for solving by graphing. Again, we're only dealing with a number line now because we have we want to know where x squared minus 6x plus 5 is less than or less than 0. So that means I just want x values. I don't care about the y values. So my answer is going to be a number line, but you can use the quadratic to figure out how to do it. So to graph it, use your graphing calculator. You can just sketch these. And when you use your graphing calculator, you find that the zeros are at 1 and 5. Now, here's what you have to look at. This is not equal, so you have to have an open circle. And again, when you graph this on your calculator, you should get a parabola that looks kind of like this. Now, I don't care about dotted here. You can dot it if you want, but we're not even looking at the graph itself. We're looking at what values of x will satisfy that. So we're looking at this number line here. That's it. But I do need to see the sketch. So you can either test a point or think about it as an AND graph. If it's an AND graph, the solution will be between these two. So that means that x will end up being between 1 and 5 for this problem. You can do a test point to double check. Pick 0. 0 does not work, right? Well, it shouldn't work. Let's look up here. 0 plus 5 is less than 0. That is false. For these ones, when we do number lines, we always do true. We've never shaded the number line. We've never done number lines false. So these will be correct, like with when we are doing absolute value inequalities or inequalities. So okay, so that's it. You just find the intersection points. You find your zeros. Those are your endpoints, and go from there. All right, so let's do another one. Let's type this in and get a sketch. And basically all I need from you is, here's this parabola, here is the number line for the parabola, and it looks like it goes about there. I probably should have drawn the axes first. My two zeros here will be filled in zeros, and I need these coordinates, and I should have actually written the coordinates here. This is 5, 0, and this is 1, 0. So this is what I expect from you when I say solve these by graphing. When you have no y's and I just want the x value, I need these points. So you should get point 686, 0 for that point, and you should get, when you do second trace 5 on your calculator, again I'm assuming you guys know how to do that. You can look back at other videos to see how to do that, or ask me in class again, and you get the other point to be that. So again, a quick step is greater will be an OR graph, so it'll probably end up looking like this. So all the values that are on these red lines will work for this quadratic inequality. Again, double check by plugging in 0, 0. 0, 0 shouldn't work. because it's not part of this thing. So 0, 0, so negative 3 is greater than 0. No, it's not, and that's good because we don't have that as one of our solutions. So that is how you solve graphically. Just graph the quadratic, sketch a graph of it. Give me the zeros, because those are the points for x where it could go negative or positive, because they're zeros. And look at the graph. The graph goes from positive to negative, negative to positive. Okay? So we want the graph when it's greater than 0, positive. And there we are. Here we wanted it less than 0. Well, sure enough, if you look at the graph, isn't this graph below 0 here? So it kind of makes sense. Alright, so now we're going to do it algebraically, and it's basically the same thing. You're finding the zeros, and then you're going to do test points. Okay? So in order to find the zeros, though, we have to factor this. So that's what we're going to be doing. So we got x squared plus 2x minus 8 is still less than or equal to 0. So, in order to do this algebraically, you have to find your, like I said, your test points. So, to factor this, you get x plus 4 and x minus 2 is less than or equal to 0. So that means that if I set these equal to 0, my critical values, or my turning points, or where the graph will go from negative to positive, are at negative 4 and 2. Okay? These are called your critical values, which, again, are your zeros. You found them on your graph if we did it graphically. So here's what you do. We know that, again, it's going to be a number line. And I'm graphing my negative 4. I'm going to graph 0 just because we like to have 0 on our number line 2. Now, first thing you have to do is look at, can it equal it? We have equal to, so yes, it can. So we are going to have dots that are filled in on our number line. And now we just have to decide where is the rest of this happening. So we have to do test sections. So think of this as we're testing each section where the zeros are. So I'm going to use the point x equals negative 5 for this section. I'm going to use x equals 0 for that section. I'm going to use x equals 3 for this section. Okay, so here we go. I'm just going to test it in, you can test it in each piece, but I'm going to just test it in my factored form. You can do either one. So I'm going to do negative 5 plus 4, negative 5 minus 2. Is that less than or equal to 0? And I have to see this work for each one. Okay, I do not just want an answer here. So this is negative 1. This is negative 7. So this becomes 7. Is 7 less than or equal to 0? No, it's not. This is not part of it. Let's do 0. We got 0 plus 4, 0 minus 2. And again, you could also use the original, and that's fine also. So you get 4 and negative 2, which means negative 8. Which is true. So we know that this section will follow suit. So we're going to shade that in. Oh, and then, not shade it, we're going to just make sure that that's part of our number line. And we still have to test this one over here. So we have 3 plus 4 and 3 minus 2. And sure enough, we get 7 times 1 again. And that is not less than or equal to 0. So we are not going to shade that. And again, to double check, that was a less than, so it is an and graph. But again, this is how you solve it algebraically. You find the middle point, you find critical values, and then decide which section makes that true. So why don't you guys try the next one on your own? Pause the video now if you want to, and then otherwise you could follow along right now. So solving algebraically, again, make sure that everything's on one side and find your critical values first. So 6 is what? 6 and 1. So we can do x minus 6 and x plus 1. That doesn't work. I can't factor today. Sorry, guys. It actually will be negative 3 and negative 2. How about that? We'll do that one. All right. Negative 3, negative 2. Multiply to positive 6 and add to negative 5. So my critical values then are going to be 3 and 2 when you solve this. So I get x equal to 0 or 3 and x equal to 2. Now, because it is not an equal to, though, those are going to be open holes on your graph. So here's my graph. Let's do this in black so you can see it better. Again, we could also solve by, this is basically a quadratic that goes through. So here's the 0, here's the 2, and here's the 3. We're going to have open circles here, and we have to test each section. So I'm going to just subdivide it. Okay, so the first one we're going to probably test x equals 0, x equals 2.5 here, and x equals 4. That's what I would probably do. Alright, so let's do that. So we have 0 minus 3 and 0 minus 2. See if that's greater than 0. We get negative 3 times negative 2. We have to see if that's greater than 0. So you get 6 is greater than 0. That is true. So this will be part of the answer. Let's test 2.5. 2.5 minus 3. We don't have a lot of room in here. 2.5 minus 2. So you get negative 0.5 times 0.5. So you get negative 0.25 is greater than 0. No, it's not. Okay. And finally, we'll do 4. 4 minus 3. 4 minus 2. You guys should see for sure that this will work. But again, I need to see your tests so you can verify to me that it does. You can't just say this is it. I'm grading on all of that. Okay? Alright, so, and again though, it makes sense because it was a gray tour, so it is an OR graph, and it matched. Okay? So this is how you solve a quadratic when we have it already set equal to 0. You solve it algebraically. Solving it graphically, you just graph the parabola and make the number line between them. And the other stuff with the y's was just shading and graphing the whole quadratic. Okay, so that is graphing quadratic inequalities.